Hello and welcome to Martin Maths. We're continuing our preparation for the GCSE Maths exams. We're going to go through the higher paper 2 now, but note question 1 to 7 are the same as in the foundation paper 2 latter stages. So do have a look at the foundation paper 2 video that I've posted, and we'll jump straight into question 8, because as you can see, question 1 all the way up to question 7 are the same as in the latter part of the foundation paper. So question 8 says, x is written correct to two significant figures. Result is 1.9, one significant, two significant figures. So we want to know what the error interval is. So what numbers could have been rounded to 1.9? Well, for two significant figures, we look at the third, so it'll be 1.95 and 1.85 there. Okay, expanding and simplifying, we've got triple brackets here. So I'll start with these two. X squared minus 2x plus 7x minus 14. We'll simplify that. X squared plus 5x minus 14 times x plus 3. You're going to get x cubed plus 3x squared plus 5x squared plus 15x minus 14x. And then 3 times 14 is a calculated paper, so is minus 42. Collect the like terms, there's no other cubes, plus 8x squared plus x, because 15 minus 14 is 1, minus 42. And there we go. That's a nice 3-mark question for expanding 3 brackets. Just watch your signs there and make sure you collect all the like terms. This is a probability question. Shakir has to complete 2 tests. He can either pass or fail. Probability that he'll pass the first test is 0.87. And if he passes, then the first test, he'll pass the second test is 0.94. So if he does better on the first, he'll do better in the second. If he fails the first test, he will pass the second test only by 0.3. That kind of makes sense. So we're now going to complete the probability tree diagram. So I've used the information they've given us there for the pass rates. Now all of these should sum to, each of these should sum to 1. So I'll do 1 minus 0.87 is 0.13. 1 minus 0.94 is 0.06. And 1 minus 0.73 is 0.27 is a calculator paper, so do use it. Then work out the probability that Shakir passes at least one of his tests. So he could pass and fail, fail and pass, or pass both, same as 1 minus probability of failing both. So that'll be 1 minus 0.13 times 0.27. So at least one could be both, or at least one of them. 0.13 times 0.27. And then I'm doing 1 minus that. 0.9649. Okay. You could have done passing both plus probability of fail and pass plus probability of pass and fail, and that should add up to that same answer there. Okay, question 11 is about graphs. The graphs of y against x represent 4 different types of proportionality. So y proportional to x squared, that would be this graph D, curving up, that's x squared. Y equal to, or proportional to x, that's linear, that'll be A, that one there, y proportional to x. That's the reciprocal, 1 over x, so that'll be B, and this one here will be C. D, A, B, C will be your answers. Let's move on to question 12. A is the point 713, B is minus 321, C is 1523, and M and N are midpoints. Work out the distance between M and N. So let's first work out what M is. So what we need to do, find the midpoints, we add the two sides. So M is midpoint of AB, So we're going to do 7 minus 3 over 2 and 13 plus 21 over 2. So I get 2 and what's 13 plus 21? 34 divided by 2. I get 217. Midpoint of BC is minus 3 plus 15 over 2, 21 plus 23 over 2. That'll be 12 over 2, which is 6. And that'll be 21 plus 23 divided by 2 is 22. So now I have 217 and 622. For the distance formula, think about Pythagoras. It's the square root of the difference of those numbers. So I'm going to see 6 minus 2 squared, 22 minus 17 squared, which will give me the square root of 16 plus 22 minus 17 is 25. So I'm going to use my calculator here. 16 plus 25 is 41. Take the square root of that. It gives me as root 41, but get a decimal point. 6.4 something. Said to correct one decimal place, so that's one decimal place there, because that's the square root of 41. A nice 3-mark question there, midpoints and understanding Pythagoras and distance formula. Question 13, prove algebraically that 0.0723 can be written as 241 over 3330. So what we need to see is where the repeated numbers are, and the dot there and the dot there means those are repeated. So if I shifted them by 10 or 100, it's not going to line up. So I'm going to say x is that, then 10x is 0.7237, and so on. And then I want them to fall away, so I'm going to multiply by, say, 10,000 to shift them by 3 more places, so that I'm going to have 237 lining, or 723 lining up after the decimal place. So it's going to be 723.723. And then if I subtract those, then I will have what I need. So if I do 10,000x minus 10x, I will end up with 723. So I'm going to have 9,990 x equal to 723. So x is 723 over 9990. I'm going to assume that I can divide 723 by 3 and give me 241, because that's what they wanted there. So there we go. Or if the calculator might have done that if I'd done 723 over 9990. Yeah, it does. 241 over 3330. Okay, a nice 3-mark question there. Recurring decimals as a fraction. Y is proportional to x squared. So y is equal to some value k times x squared. So let's work out what that k is. Y is 3 when when x is 0.5 squared. So that's over 4, so k is 12. Now x is inversely proportional, let's call it j over w. So when x is 2, j over 0.2, so j equals 0.4. So then we have to find the value of y when w is 2. So when w is 2, x is 0.4 divided by 2. So 0.4 divided by 2 is 0.2. And then I'm going to square that. So it's 1 over 25. So then y equals 12 over 25. So 12 divided by 25 is 0.48. 0.48. 5-mark question there, lots to do. You have to work out what k was, you have to work out what j was, and then once we plug in for x, we can then find for y. Okay, I'm going to go through this one quickly on histograms, just to give you the answers here. Use the histogram to complete the table. That'll be 3. Use the table to complete the histogram. You should have heights of 4.5 and 1.4. And then working out an estimate for the median, it's 18.5. I'm going to leave you to work on that. Question 16. AD is parallel with these arrows to BC. We've got to calculate the area of triangle BCD. Okay, so we could start off with BD over sine 112, using the sine rule in this triangle here, equal to 7.9 over sine 42. So BD equals 7.9 sine 112 over sine 42. So I'm going to do 7.9 times sine 112. Divide that by sine 42. And I get 10.9. Okay, so that'll give me 10.9 here. These are parallel, so that angle there is also 42 because of alternate angles. And then you'd have to use the area rule if you've got the included angle there. Okay, and you should get an answer of 56. A half, remember it's a half AB sine C. So we could just check that. I'll do 0.5 times 10.9 times 15.3 sine 42. And I get, correct one decimal place. It is 56 because I've got that and that area there. So it's a half 10.9 times 15.3 sine 42 using sine rule and area rule. Okay, so you have to use sine rule, area rule, and parallel lines. So there's a lot going on in that question. Nice 4-mark question there. Okay, question 17. We're to show that there's a change of sign between 1 and 2. So if I put 1 in there, I get 1 plus 2 minus 6. For 1, that'll be 3 minus 6 is minus 3. But for 2, I'm going to get 8 plus 4 minus 6, which is 6. So we have a sign change, and that's all we need to show that the graph has kind of gone from below the x-axis to above the x-axis. So there's a sign change. Right, x cubed plus 2x minus 6 equal to 0. Let's rearrange it. I'm going to move the 6 to the other side, noticing what they want us to put it in. Then I'm going to factorize out x squared plus 2. And then you should see if I divide through by 6, I've got what they want. Okay, it's always nice when they've got something to show. Right, starting with x naught being 1.45. So x1 is going to equal 6 over 1.45 squared plus 2. So 6 divided by 1.45 squared plus 2. I get 1.4625. Use that for x to the 2. So 6 divided by my answer squared plus 2. I get 1.449. Because that's now the answer and I've got that written in my calculator, I can just say, press it again. X cubed is equal to 1.4629. Press it again. X to the 4 equal to 1.45. Well, 449. Press it again. 1.46. I'm going to leave it at 1.45 or 1.46, something there. Okay. Sorry, I did say 4 decimal places. My mistake, sorry. 1.4484. Leave it at that one. Okay. Question 18 is a proof in vectors. I'm going to leave that one for you there. Move on to question 19. G of f of minus 3. So we put minus 3 into f first. G of, so 2 times minus 3 plus 3 squared. That'll be minus 6 plus 3, which is, and then square that, which would be minus 3 squared is 9. So G of 9 is going to equal 18 minus 1. It'll be 17. Okay, we have to do the inside one first. And then G to the negative 1 of x means we have to actually replace those. So if I said y equal to 2x minus 1, y plus 1 equal to 2x. So x equals y plus 1 over 2. And now replace it, so invert it. It'll be x plus 1 over 2. Okay, so that's a bit of functions there. We're nearly there. Only 2 more questions, and we'll have done the whole of the higher paper. Right, 14 over 3x minus 21 plus 2 brackets, x plus 4 divided by 2x squared minus 6x minus 56 over 2x plus 3. Let's see if we can do any factorizing out. X minus 7 there. X plus 4 times 2x plus 3 over. Now, we're going to have to factorize that. I'm going to assume there might be either a 2x plus 3 or an x plus 4 there. Well, they're all multiples of 2. So I could take out a 2. X squared minus 3x minus 28. And let's see what else we can do. If I do my first, last, middle, x squared, x and x, minus 28. 7 and 4 will differ by 3. I want negative, so it's going to be negative 7 plus 4, and I want that. I wanted x plus 4. So 14 over 3x minus 7 plus, I've got x plus 4 times 2x plus 3 over 2 times x minus 7 times x plus 4. Those cancel. And then I've nearly got the same thing. If I multiply this one by 2, I'm going to have 28 over 6x minus 7. Multiply this one by 3. 3 times 2x plus 3 over 6x minus 7. Now I can add them together. 28 plus 6x plus 9 over 6x minus 7. 28 plus 9 is 37. So 6x plus 37 over, what form do they want us in? They want us to expand that bracket. So 6x minus 42. And there we go. Okay, you have to need some factorizing, some algebraic fractions. So some division of fractions, factorizing, and adding algebraic fractions. Lots in there. Last question here, question 21. Vicky has a collection of medals. The Venn diagram gives information about the number of medals. So the universe is all the medals. A is the English medals and B is the gold medals. Vicky's going to take at random a medal from her collection. Given the medal is gold, so given that means it's conditional. So it comes out of the gold ones here. The probability that the medal is English, so it's got to be English and gold. That must come from this section here. So x out of all the golds, which is x plus 5x minus 3, is equal to 2 11s. Okay, because that's the overlap, the intersection. So let's multiply through that. I'm going to get 11x equal to 2 times 6x minus 3. 11x equals 12x minus 6. So x equals 6. Work out the number of medals in Vicky's collection. So she's got 7x minus 11 plus x plus 5x minus 3 plus that 34. So that's 8, 13x minus 14. Let's do the calculator because I've got it. 13 times 6, 78 minus 14 is 64. But then we've also got that 34 sitting over there. So 64 plus 34 is 98. And there we go. That's 4 marks to finish that paper. Algebra and probability in there. Have a think about what was happening here, English and the gold. It's the intersection to give us that. So that intersection out of all of that, which is x plus 5x minus 3. Okay, that's the complete higher paper 2. Thanks for watching. Don't forget to like, subscribe, and share. And look out for more videos on the Martin Maths channel. Good luck for your exams.